So this is a brief presentation about energy devices and what surgical trainees need to know. So the aim of this presentation is to review the basic physiological principles, to try to define the terminology, and to go through recommendations for safe use, and look at the recently emerging technology for diathermy. So diathermy and electrocautery are usually believed to be two identical terms. However, if we look at the origin of the words, you have the Greek word dia in the word diathermy, which means through, therefore meaning that the thermal energy needs to travel for us to be able to use the word diathermy. While cautery comes from the Greek word for branding iron, which means that the thermal energy just remains in one place. So up until the 20th century, what we had was cautery, but then Dr. Bovie came along and created alternative high frequencies at 300,000 hertz in the radio frequency spectrum. He did that so as to avoid stimulation of the muscle and nerves that happened in lower frequencies. So what happens within the tissue when you apply diathermy is that the polarity of the cells within the tissue changes rapidly due to the alternative current, which makes the ions within the cells to oscillate, creating friction and therefore thermal energy, and this is what causes the actual tissue effect that we see when we operate. So as we said before, we need a current, we need movement of the thermal energy in order to be able to talk about electrosurgery or diathermy. And the two most common circuits that we know is the monopolar and the bipolar. In the monopolar, you have the active electrode, then the energy goes through the patient and it's received by the dispersive electrode that closes essentially the circle. In bipolar, as shown here by the yellow arrows, the energy goes between one jaw of the electrode to the other jaw of the electrode, and as you can see, the area of energy is quite distinct between the two. So if we need a more confined area to apply diathermy, say for example if we have a patient with a pacemaker, we would opt to use, or it would be safer to use, bipolar instead of monopolar diathermy. And we have these devices that we're all familiar with, and you can see that we have the cut current, coagulation current, and then overall 4 different types of current. So it's really important to know the correct terminology, especially when we are asking people to adjust the energy devices for us. So as we said before, we have 4 modes of diathermy, or 4 waveforms, and while it's important to look at the waveforms, it is a bit more important to see how the waveform influences the tissue effect. So the continuous wave or the cutting mode is what vaporizes tissue. So if you want to cut through tissue rapidly, the best way to achieve that is by using the non-contact cut waveform. So for cutting, the best way to achieve cutting with diathermy is to keep your electrode close but not in contact with the tissue. If you want to achieve a little bit of coagulation and a little bit of cutting, then you might want to consider using the cutting mode but in contact with the tissue. On the other hand, coagulation, if you want to achieve coagulation, you need to, of course, use the coagulation waveform, but that is a contact waveform. So you need contact with the tissue in order to achieve coagulation. And then you have fulguration. As you can see here, the diathermy is applied in a wider area with fulguration. If you think, for example, that you have taken the gallbladder of the liver bed and there is generalized oozing, you might want to consider using again this non-contact waveform to achieve diathermy. And unsurprisingly, the tissue effects are associated with the waveform, as we explained before, the power settings. So the higher the power, the more effect the thermal energy will have. The size of the electrode, for example, if you have a pointy tip, you will have more concentrated thermal energy there. The time, so the more the time, the bigger the effect. The type of the tissue and the manipulation of the electrode. We said before that some waveforms work better as contact and some as non-contact diathermy. Also, if you have an eschar at the end of your diathermy tip, a considerable amount of the energy that you're using will go to that eschar, which means that you will be forced to use greater power, hence risking a bigger thermal damage or tissue effect. That's why it's very important to clean the eschar at the tip of the diathermy. Now, going to common pitfalls, it's always important to make sure that the diathermy instrument is not in direct contact with any other instrument that can transfer the heat elsewhere and therefore cause an alternative sideburn. Also, installation, if there's any defect in the installation of the instrument, that is another way to create thermal damage in an area away of the intended application of diathermy. Again, and we have to always make sure that we're operating in a closed circuit, otherwise diathermy will unfortunately find another way to travel, as in this case here, where you can see that it's causing thermal damage on the bowel. So how do we go about avoiding complications? So carefully inspecting our instruments before we use it to see if there is an installation failure, and we use the lowest possible power settings, voltage, time. Also, we always make sure that we activate in a closed circuit and not in close proximity to other instruments. So besides the the hook diathermy, we have the vessel sealing devices. Such as the ligature and the end seal that can withhold up to 3 times the systolic blood pressure, much like surgical clips. Their advantage is the minimal thermal damage, and of course the reliability of having continuous feedback and the ability to regulate the energy given according to the tissue resistance. So this is one of the devices, the ligature, and the activation button is found here. And another one of the devices, the Ensil, which has the ability to bend, which is something that could be useful during dissection in the pelvis. And then we have the ultrasonic devices. This is the harmonic. They use piezoelectric discs and can ligate up to 5 millimeter vessels. There was the addition of the advanced hemostasis feature, so now they can ligate up to 7 millimeter vessels, and of course you are recommended by the manufacturer to make sure that you always include the full length of the vessel that you want to ligate within the jaws, and also to do it under minimal tension. So that was a quick overview of diathermy and energy devices for surgical trainees. Thank you for your time.